When it comes to MOSFET burning, it is usually because it is working outside the SOA or has overcurrent, such as the MEMS tube has overcurrent. For example, the maximum allowable current of the PMOS tube in this circuit is 50 N. When the MEMS tube is turned on, the maximum current reaches 80 plus, and this current is very large. At this time, the PMOS is used beyond specification. We can see from the SOA curve that it does not work in the SOA range, which will cause damage to the PMOS. What if we choose a higher current PMOS? Of course you can, but the cost will be higher. We can choose to adjust the peripheral resistor or capacitor to make the PMOS turn on slower, so that the current can be reduced. For example, adjust R1, R2, and cross-connected capacitors between GS. When CGs is adjusted to 1/2, the maximum IDs is only 40 N, which is enough in terms of current and meets the 80% duration. Next, let's look at power from the SOA curve. The turn-on time at the MEMS tube is about 1 ms, and the maximum power at this time is 280 watts. The normal thermal resistance of the chip is 122 degrees Fahrenheit per watt, and the maximum junction temperature can be 300 degrees Fahrenheit. Assuming that the ambient temperature is 77 degrees Fahrenheit, the instantaneous power that can be sustained in 1 millisecond is approximately 357 watts. The actual power of the PMOS here is 280 watts, which does not exceed the limit, which means that it works normally in the SOA area. Therefore, when the current surge is large, when the MEMS tube is turned on, the CGS capacitor can be appropriately adjusted to allow the PMOS to work in the SOA area, thereby avoiding the problem of MEMS damage. If you have any questions about MOSFET product technical solutions, you can leave a message in the comment area. I will give you the answer here. VBsemi-MOSFET manufacturer focusing on MOSFET R&D and manufacturing for 20 years.